Yes, friends. Here in this topic, I will take motion of cyclist on flat circular roads. You yourself might have experienced that when you move on circular road on a cycle or two-wheeler, you get inclined away from vertical position towards center of circular path. Why this is there? We never think about that. कि क्यों मुड़ रहे हैं हम? Here I have shown this cyclist moving on cycle on circular path to radius r. Here the G, the center of gravity, and cyclist and cycle both. Symbolic diagram there. Actually, it is the symbolic diagram of cyclist. Right? So center of gravity here, so weight mg of cycle and cyclist together. Cyclist and cycle together act here. Now the inclination of the cyclist from vertical is theta. This is the normal reaction of road n. मैंने बताया ना normal reaction are always not normal to surface. It depends in which direction the plane is there. Now this normal reaction n has been resolved here in two components, one in horizontal direction n sin theta, other vertical direction n cos theta. If theta be the inclination of cyclist while taking turn on circular path with circular path of radius r with constant speed v, then normal reaction of road on cycles and cyclist can be resolved into reactor components as shown in figure. Here n cos theta is the horizontal component and provide here n cos theta, n sin theta. N sin theta is the horizontal component of normal reaction. This component provides necessary centripetal force necessary central force is provided by n sin theta. This is n sin theta here. In video, some trouble may occur because of reflection of light. N sin theta is the component of normal reaction, है ना भाई, which is acting oriented towards center of circular path and hence provide necessary force. While n cos theta, vertical component of n balances the weight. If n sin theta is able to provide a central force and n cos theta balance the weight, then the cyclist will take turn safely on this path. And we can write here n sin theta equal to m v square upon r. You know v equal to r ओमेगा भी होता है ना, तो यहाँ m r ओमेगा स्क्वायर लिखते हैं अगर v स्क्वायर करोगे, और m cos theta equal to mg. n cos theta provides, दिखाई दे रहा कि नहीं? n cos theta is providing necessary n cos theta is balancing the weight, ना भाई, balancing the weight. n sin theta equal to mv square by r. n sin theta is the horizontal component of normal reaction which provides necessary centripetal force. Okay, while n cos theta opposite to weight and balance equate. If we divide these equations, we get tan theta in dividing 1 by 2. Dividing equation 1 by 2. What do we get? Tan theta equal to tan cancelled v square upon rg. So this is the required inclination given by tan theta equal to v square by rg, v square. If keeping the same inclination you increase speed, then you have to increase the radius of circular path. So when I always ask, when you were learning cycling and you took first turn on circular path, you might have fallen. Every person when learning cycling take turn, so he take very sharply, and because he is in the habit of moving very fast, due to large speed, what may happen? You may fall down, you may get slip because theta required is there. You did not you don't try to get incline away from vertical, and due to that fact, you are not able to get centripetal force by this component, and hence your cycle will slip outward. So tan theta, or you can write v is equal to under root rg tan theta. So this is the safest speed, maximum speed at which a person can take turn on circular path by leaning only, not using force of friction. यहाँ पर force of friction यूज नहीं हुआ to obtain central force. So cyclists get lean towards center away from vertical, to obtain necessary centrifugal force. I am repeating again that centrifugal force is the force required to change the direction of motion. It is not produced by itself. ये तो पैदा करना होता है नहीं. It has to be applied there on the body, which is moving on circular path. So if you want to increase speed at same radius, you have to increase inclination. If you want to increase speed v at same radius, then to maintain balance or to avoid slipping, you have to increase inclination theta away from vertical. So in motorcycle race, in TV or film, you might have seen that cyclists just get lean horizontal. थीटा बड़ा करने के लिए they get very much away from vertical. कई बार तो बिल्कुल ऐसे हो जाता है. तो क्यों होते हैं वो? Because they want centrifugal force. Larger value of theta, greater the component. Because you know, value of sine theta increases as angle is from 0 to 90. At 90, sine 90 is 1. लेकिन वो कुछ नहीं होता, फिर तो इससे रिएक्शन नहीं होगी, तो थीटा ऑलवेज रिमेन लेस देन 90. तो इन केस ऑफ टू व्हीलर, द ड्राइवर ऑफ टू व्हीलर can obtain central force by getting inclined away from vertical. Then what about three-wheeler and four-wheeler? A vehicle having three wheels or four wheels cannot get inclined like this. So when it moves on flat road, then only thing there is force of friction, which can help the three-wheeler or the vehicle which is either three-wheeler or four-wheeler. It is the force of friction which can provide necessary centrifugal force. And wherever friction acts, friction produces heat. If you rub your hand like this palm, so heat is produced. So when the tire will slip continuously, try to slip outward, so force will be acting there, and that force of friction will produce sufficient amount of heat, and by getting that heat, tire get heat up, and hot tires get wear and tear faster. So what to do to avoid the wear and tear and to increase the safe speed of turn? So for that, what we do on circular track, we raise the outer edge of the road, which is also called bank, outer bank of road, little higher than inner one, and that is done by calculation. We obtain that by calculation, and to give artificial inclination to the vehicle. They are called bank road. Outer edge, outer bank is raised little above the, अगर ये सर्कुलर पाथ है यहाँ पर, तो ये बाहर किनारा अगर है तो ऐसे उठ सकते हैं, ताकि व्हीकल को अपने आप तिरछा हो जाए. कि अगर थीटा है तो नॉर्मल डायरेक्शन वर्टिकल से, and that inclination may provide the centrifugal force. In next video, I will take case of bank road, motion of car on a bank road, and why banking required. I will dictate in the next video. Thank you.